Hello and welcome back to another video. In this problem, we're told that figure 1 was recorded by an instrument operated by the California Department of Mines and Geology at the University Hospital of the University of South California in Los Angeles. We're asked to use this figure to estimate the range of the vertical ground acceleration function at USC during the Northridge earthquake. So we have a function here, which is representing an earthquake, and we're asked to find the range of it. So in the xy plane, which is what we're looking at here, it's just in terms of a and t, the range is the value of y, the range of y values that the function can take. So if we're looking here, what we have to do is say, okay, what is the minimum value and the maximum value on the y-axis? So if we just look visually here, this point is a pretty clear maximum. And if we look over here, there's maybe a couple candidates, but this one looks like the lowest. And we can just assume that this is a continuous function. So therefore, all of the values in between these 2 points are going to be met somewhere in the function. So the range is going to be an interval from the y value of this point to the y value of that point. Right, so the lowest value, if we're looking on here, this is negative 50, so maybe equally far down, this would be negative 100. And this falls somewhere in the middle. We can just call it negative 80 perhaps. Over here, we're above 100. Maybe this is 150. So this is somewhere in between. We can just call it 120. We're just estimating here, so you just have to get close. So we're going to say that the range of the vertical ground acceleration function during this earthquake is negative 80 to 120, inclusive from these points. And that's going to be your final answer.